Hi, my name is Sophia, and I'll be giving Team 8's Design Phase 1 overview for our product, the BIMBot. Through this presentation, I'll be discussing the 4 phases our team took in order to design and plan a concept for our product, the BIMBot. The BIMBot is a solution in response to VTEP's challenge of developing a solution to problems Virginia Tech students face. Furthermore, the VTEP challenged us to ensure that our product fit in a given specification described by an innovation charter. Through this presentation, I will be describing our process in the product planning, our results and customer needs, our analysis and product specifications, and our experiment for economic analysis. So first, I'm going to begin with product planning. In this phase, our team generated 12 different ideas. From these 12 ideas, we narrowed them down to 4 based on innovation charter requirements and specifications. With the remaining 4, our team conducted a real win-worth analysis that described whether each product had a real audience or real solution to problems students face, as whether it was worth pursuing, so it made a profit, and lastly, whether it was winnable, would it be able to stand against competitive advantages or competitors on the market. So our team chose the BinBot, which is an automatic sealing trash can. We felt that it was a real issue and a real solution to a problem Virginia Tech students face. As you can see in this image, this is a picture of Center Street after a tailgating party, or after a tailgate. And you can see that students have littered their trash everywhere. This shows that Virginia Tech students do have issues when it comes to delayed disposal, and then we can discuss those later on throughout the presentation. Furthermore, in this presentation, I will also discuss how our product is worth pursuing. So our product is an iteration of currently existing products, which is why our product is actually winnable. It does stand against competitive advantages. As you can see, this is a current product on the market, which is an automatic trash can sealer. Our goal as a team was to take these kind of mechanisms and fit it onto basic regular trash cans that students have. Once the trash reaches max capacity, the BinBot will automatically steal the trash. Then it would send a notification to the users on a display screen saying take out your trash or reach max capacity. This is different from current products on the market, as it's not really seen and you only can see it right here, and it's not adaptable to different types of trash cans. It's only just sold as the trash can itself. So with that being said, our team developed a mission statement to establish the BinBot's description, as I previously mentioned in the earlier slide. We also wanted to identify goals in this area as well, and one of the main goals is to help Virginia Tech students maintain a cleaner environment. So rather than having their trash continuing to overflow, we would send reminders out to them saying that their trash needs to be taken out. Furthermore, we identified the overall student population at Virginia Tech to be our primary market. This is because we felt that our product didn't just suit us a very specific part of the Virginia Tech community, but rather the entire community itself, as we believe all students could benefit from this. Furthermore, our team developed a Gantt chart in order to organize the multiple tasks we would have while developing the BIMBot. As you can see right here, this is the longest task we have, which is the design mechanical task. And that is because our product is heavily focused on the mechanics of being able to seal the trash bags closed. Furthermore, in parallel, you can see how the detailed electrical design is right underneath the mechanical design. Since our team aims to have the BinBot push a notification to the users, these can be done hand in hand as they don't really coincide with each other's production and planning. Next, our team developed a use case. And so in this use case, we determined that in order for the BinBot to fully function as it should, users have to take out the trash. If they don't, it'll just always remind them that it's at max capacity, and it would never be able to automatically seal the trash bag. And here you can see a kind of example of how we believe our push notification to the trash can will look like. And this is an AI generated image of our bin bot, minus the fact that it's a overall trash can and not just like an extension to the trash can. So next I'm going to talk about customer needs. So our team interviewed 8 different customers all across the Virginia Tech campus. And in these interviews, we determined that most Virginia Tech students kind of use these types of trash cans, the plastic ones that are kind of big for kitchens. We asked them in these interviews what they liked and disliked most about their trash cans, as well as any other comments that they had about them. And through these, we kind of determined what customers needed for their trash cans. And we then compiled the most common ones into this chart over here, which we determined were the ability to hold large amounts of waste, identify when the trash can is at max capacity, the bin bot is cost effective, it's adaptable to different types of trash cans such as these, and is able to automatically seal different types of trash bags. So through these different specifications we found, or customer needs we found, we asked our customers in our interviews to rank them from 1 to 5, 1 being undesirable needs and 5 being most desirable needs. We found that customers mostly valued the ability to hold large amounts of trash, as well as the ability to automatically seal the trash bags once it is full, as you can see with the 5 and 5 over here. Next, our team evaluated the product specifications based on our customer needs. So as you can see, we developed 9 different types of product specifications, them being capacity, whether our bin bot could fit on large capacity trash cans, the price, works in various sizes, so adaptability, loudness, so how loud our notification is, screen brightness, so how visible our screen is, whether customers can actually see it, bag secureness, whether the bag won't slip off the bin bot, size, weight, and convenience, whether it's easy to put on or off a trash can. So from those specifications, we aligned them on the top row of our QFD analysis model, and then in this row we added our customer needs, and then determined the correlation between those. It was found that the capacity, adaptability, and convenience of the bin bot were the most important to the customers, as well as they fit with these specific specifications, highlighting the importance when it comes to designing the bin bot. Now I'm going to move on to economic analysis. So our team had a fixed cost of around $10,000 to cover the cost of things such as rent for a office building. And then we also had a fixed cost for manufacturing of around $20 per unit. A variable cost for manufacturing cost of $20 per unit, and then a selling price of around $50. With those types of guidelines in place, we determined that the break-even point was around 334 units, meaning once we sold 334 units, our product will eventually start making profit, as you can see in this margin. So through this presentation, we were able to identify that the bin bot was in fact a real problem among college students, as many students have trouble with overflowing trash and delayed disposal. Furthermore, through the customer interviews we conducted, we found that the key needs that customers had were reliability, adaptability, and sustainability. In product specifications, through a QFD analysis model, we were able to translate the customer needs into real technical and engineering requirements. Lastly, in economic analysis, we determined that our product is in fact profitable, as after 334 units, our team would be able to make profit. So through this presentation, I was able to explain our process of how we developed different parts of the bin bot and how we were able to design for those, as well as cover the fact that the bin bot is a simple yet scalable solution to improving the cleanliness and convenience for college students in different living environments. Thank you so much for your time.